So let's look at an example. So take a look at that problem. So as this system oscillates back and forth, the block that's on top must remain on top of the block that's on the bottom. So it's coupled motion, they're going to have the same acceleration. From our simple harmonic motion equations, we know that the acceleration is going to equal omega squared times x. And if we want the maximum acceleration, we're going to have to use the max amplitude of x. Now, what force is going to be accelerating the top block? It's going to have to be friction. Those are the only left to right forces that's the only left to right force that can act on it. So friction is going to cause little m to accelerate. And what the frictional force is going to be equal to is the mu mg. And the acceleration is going to be the max acceleration while it's oscillating. Okay. And again, notice with this equation, we're not worried about the sine and the cosine because we're looking at maxes. The max acceleration is when you're going to need the greatest frictional force. So with this equation, and one of the other ones we've solved for before, which is omega squared is k over m, we can make this substitution in for omega squared. And we're looking for the maximum amplitude. So just manipulate and solve. Here's the numbers plugged in. We have to use the total mass that's oscillating, so you have to add the two together. And if you plug that into the calculator, you will get the answer listed next to the problem. So you will use this equation often. I think even on the video I said that's going to be an important equation used to solve problems, and that one as well.